Hello everyone. In this session, we are going to solve some problems on viscosity. Okay, we'll read the problem and note down the data. Glycerin has a density of 1260 kg per meter cube. So I'll write it down as rho equal to 1260 kg per meter cube, and a kinematic viscosity of 0.00183 meters square per second. So kinematic viscosity is represented by nu, and it's equal to 0.00183 meters square per second. What shear stress is required to deform this fluid at a strain rate of 10 raised to 4 per second? So what is required is shear stress. The shear strain rate, we represent it as du by dy. That shear strain rate is directly given as 10 raised to 4 per second. Strain is not having any units, but strain rate, when you want, obviously it will be per second. Now the equation that we know is tau is equal to mu into du by dy. Very standard equation of Newton's law of viscosity, where tau is shear stress, mu is coefficient of viscosity, especially dynamic coefficient of viscosity. This is shear strain. Excuse me. But nu is equal to mu into mu by rho. This is the relation that we should be knowing. Because it relates kinematic viscosity to density. So nu is equal to mu by rho. Because nu is given, mu can be calculated, because nu as well as rho is given. If you substitute the values, nu as 0.00183, rho as 1260, and if I write an equation, mu is equal to that meter square per second units and into 1260 kg per meter cube. If you look at the units, it will be kg by meter per second. I mean kg divided by meter second, which is a unit of dynamic viscosity. We have seen in earlier lectures that it is equivalent to Pascal second. So mu comes out to be 2.3058. Now I'll apply this into this value into this equation. So tau is equal to, mu is substituted as 2.3058 Pascal second, du by dy is 10 raised to 4 per second. So that denominator per second cancels with the numerator second. You will be left with only pascals. So the shear stress is equal to 23.058 into 10 raised to 3 pascals would be the units. We'll go to the next slide. So here there is a problem, a flat plate. We'll read the problem and then go on noting down the data also. 60 centimeter by 120 centimeter slides on SAE 10 oil. It is an oil specification which has got viscosity of 1.04 into 10 raised to minus 1 Pascal second over a large plane surface. So the plate has an area of 60 by 120. So what I have done here is calculated the area. Area is equal to 0.6 meters into 1.2 meters equal to area equal to 0.72 meters square. That is the area. Okay, then what force is required to drag the plate at 3.5 meter per second if the oil film is 3 millimeter thickness. Okay, one more data that has entered is coefficient of viscosity, dynamic coefficient of viscosity they have given as 1.04 into 10 raised to minus 1 Pascal second. So Pascal second is Newton per meter square into second. Pascal is Newton per meter square. So and then 10 raised to minus 1, simply it is 0.104. Okay, constant velocity. They have said it has to be moved with the velocity. So to say the velocity is constant. So it is 3.5 meter per second. So whenever there is a constant velocity, obviously acceleration is zero. Acceleration is zero indicates that the total force is equal to zero, because you know that it is F equal to m into a. Right? With that argument, if constant velocity is there, sigma f is equal to 0. Okay, we'll depict this in the form of a picture. So there is a flat surface, and there is an oil film. The thickness of the oil film is shown here. It is 3 mm. If you want to convert this into meters, you have to put 3 into 10 raised to minus 3. Then next, there is a block which is sitting on that oil film. Right, the block in the sense the plate, the size of the plate is 60 by 120, means maybe width is this way, perpendicular to the board is 60, and then parallel to the board is 120. So the surface which is touching the oil is having an area 0.72 meter square. Sorry. Now this is moving the constant velocity under the application of some force, right? The force is being applied like that, so that it moves. This block tries to move this way with a velocity of 3.5 meter per second. Now what happens is, because of viscosity, there will be resistance offered. So the resistance is opposite to the direction of motion. Now this resistive force, we represent it as viscous force Fv, and this viscous force is equal to the shear stress multiplied by area. Okay, we'll start with this equation, that is standard equation, tau equal to mu into du by dy. We'll calculate tau, because we know now mu du by dy is nothing but velocity divided by thickness. So velocity of the object is 3.5. The thickness of the oil film is 3 into 10 raised to minus 3. I get a value of tau as 121.33 Newton per meter square. That is shear stress. But what I want is shear force. I have to multiply this tau by A, the area. And for sigma f to be equal to 0, I'll conventionally apply the plus is rightwards, and then leftwards would be minus. So applied force would be F, and resistive force, that is frictional force, will be leftwards. So plus F minus tau into A equal to 0. That gives F, the applied force, has to be equal to 87.36 newtons, so that the plate is kept in motion with a constant velocity of 3.5 meter per second. Some more analysis I'll tell you. If you decrease the value of 87.36, what happens is the velocity decreases, because this resistive force will be more. But what happens is, when the resistive force is more, then velocity also decreases. So when velocity decreases, even the shear stress decreases. It continues to happen, right? So to keep this a constant velocity, you have to apply exactly 87.36. If you apply more force, then what happens is it gets accelerated, because there will be No sigma f equal to 0, F will be more. It pulls the object with a more force. Because of that, it may start moving with a more acceleration. So from this, what we can understand overall, what one should do is, if there is a constant velocity, sigma f equal to 0, and sigma f equal to 0 simply tells that applied force minus viscous force is equal to 0. Okay, we'll go to the next problem. Here there is one more. Two large plane surfaces are 20 millimeters apart, and the gap contains oil of dynamic viscosity 0.6 pascal second. So I have shown here that 20 millimeter thickness, right? So there is a plate here, there is a plane here, and in between you have got a 20 millimeter thick oil gap. Oil has oil has dynamic viscosity of 0.6 pascal second. Now, a thin plate of cross-sectional area 0.5 meter square is to be pulled through the gap at a constant velocity of 0.6 meter per second. So once again, it is a constant velocity. Keep it in mind that sigma f has to be equal to 0 because it is a constant velocity. Okay, the location of the plate will have to be such that it is 8 mm. You can see here I have placed this yellow plate at 8 mm from one of the surfaces. Obviously the other distance will be 12 mm because it is 20 and this is very thin plate. Only the surface perpendicular to the plane of the paper is 0.5 meters square. Okay, what they are trying to tell, neglecting edge effects, means whatever edge thickness and then disturbance because of that, neglecting that, estimate the force required for pulling the plate as above. Okay, this plate is being pulled under the application of force, and estimate the force. That is what is the task. How much is the force required so that this is pulled at a constant velocity of 0.6 meter per second. Now if you try to analyze, there is a resistance because of viscosity on the upper side as well as on the lower side. I have indicated FR1 or FE1 on the top, FE2 on the bottom. Okay, to calculate viscous force, I should know shear stress, and the shear stress comes into picture by Newton's law of viscosity. I have written here FV1 is equal to shear stress multiplied by area. The shear stress is given by mu into du by dy or mu into v by t, because dy, right, it is nothing but velocity divided by thickness of the film. So here I'll substitute, of course multiplied by a is there. Now mu is given from the problem 0.6 pascal seconds, newtons and seconds we are going to use. V by t, v is 0.6 meter per second, thickness of the oil film is 8 mm, so I'll convert that into meters, 8 into 10 raised to minus 3 meters. The area they have given, it's 0.5 meters square. So overall calculation gives you the viscous force Fe1 equal to 22.5 newtons. Why newtons? Because this pascal is Newton per meter square. Everywhere meters are there. Because of that, the unit of viscous force would be 22.5 newtons. This is a 1. Similarly, FV2 or frictional force written as, preferably you should write it as FV2. It will be a better way of writing viscous force. So FV2 is equal to again the same type of equation. You can just see, substitute mu is zero point 0.6, velocity is zero point 0.6 meter per second. The thickness of the oil film below is 12 mm instead of 8 mm on the top. Here it is 12 mm. So that's why this has to be put as 12 into 10 is to minus 3 meters. Again, the area exposed is zero point 0.5. If I simplify, I get by getting FV2 as 15.04 newtons. The thickness is less, the friction is more, the viscosity force is more. The thickness is large, so viscosity is, resistance because of viscosity is less. You have to make an observation of that kind. Now, under the action of FV1, FV2 and applied force F, the body is under a constant velocity. Because of that, acceleration is 0 and hence sigma f equal to 0. And here if you look at this figure, plus f minus fv1 minus fv2. So I have written those values equal to 0, which gives you f equal to 37.54 newtons. That is what is the answer. It's an interesting problem where a plate is moving inside a pool of oil having some different thicknesses on top and bottom. Okay, we'll go to the next problem. So here a square plate 50 centimeter by 50 centimeter weighing 200 newtons. Okay, weight is given. It slides down an inclined plane of slope 1 vertical to 2.5 horizontal. So this is represented here 1 vertical and 2.5 horizontal. What is the angle theta? I can calculate this. Immediately let me calculate. This is a right angle triangle because slope is shown here. 1 is vertical, 2.5 is horizontal, angle theta. Now how to find the angle? It's a right angle triangle. I can always write an expression tan theta, opposite side upon adjacent side. I have written here. And using the calculator, you can get theta equal to 21.8 degrees. Okay, theta is known. Though they have given in terms of slope, I have found theta. Okay. Now, if a thin layer of oil of thickness 0.5 centimeter fills the space between the plate and the inclined plane, okay, here there is a plate. Now, between the plate and the plane, there is a thin oil film. You can make out here. Thickness of this is given to be 0.5 centimeter. So to say 5 mm. When I take it for calculation, I should make it as 5 into 10 raised to minus 3 meters because my calculations are in meters. Okay, now there is a plate. Okay, what they have asked is determine the coefficient of viscosity of the oil. Okay, mu is being asked. Okay, what all the things that they have given, I'll list it out here. The weight is given, W, 200 newtons. The area of the plate, again, I make it clear, this area is not 0.5, 0.25 meters square. Actually, this is a plate which is sitting, and then they have said that it's a square plate. So if you can imagine that there is a plate, if I try to draw 3D effect of that plate, it will be something like that. I'm sorry, right? It is a square. So this width is 0.5, this width is 0.5, there will be a thickness seen, right? 0.5 by 0.5 area would be 0.25 meter per second, right? Okay, now the area of contact of oil is 0.25 meters square. The velocity, they say it is a constant velocity, uniform velocity. Uniform is same thing, no change. So 0.4 meter per second. The thickness of the oil film I have indicated here, 5 mm. 5 mm is 5 into 10 raised to minus 3 meters. What they have asked is uh, viscosity, right? Coefficient viscosity. Angle is calculated. Now let us analyze this equation. Anyway, you know that it is a viscous force which is given by shear stress multiplied by area. We have been using it, and shear stress is mu into du by dy, or v by thickness of the oil film multiplied by the area. Now in this I have to find mu. It is an unknown, but the velocity is given as 0.4. Thickness of the oil film is given 5 into 10 raised to minus 3. The area is given as 0.25 meter square. I'll substitute all that, and FV will be a number multiplied by mu. Okay, now let us analyze here. That is a weight. Weight is always vertical and vertically downwards. Here there is an angle theta, that is to say this angle theta, horizontal, and this is parallel to the plane. When this is theta, obviously this will be 90 minus theta, and this will be theta, because these two are perpendicular to each other. Because this component I have drawn perpendicular to the plate. This is parallel to the plate or plane. So when W and this theta is this component is W cos theta, and this component is W sin theta. So the weight component, which is parallel to the plane, will be trying to push it down. And because of this W sin theta only, it is going down. It is going down with a velocity of 0.4 meter per second constantly. Now, what is the resistive force is a viscous force over there, right? So what we have is a active force of W sin theta, which will be trying to push it down, and then there will be a resistive force of viscous force. Now, because it's a constant velocity motion, once again, the resultant force has to be equal to 0. Now here, along the plane, if you look at, the only force which is acting W sin theta and viscous force. The force which is perpendicular to that, we need not worry, because you know that forces are vectors. We have to put them with respect to some direction properly. Now I am putting this equation parallel to the plane, right? Parallel to the plane, we have got force W sin theta minus viscous force equal to 0, because it is constant acceleration. So W sin theta minus Fv equal to 0. So Fv will be equal to W sin theta. You can remember this as a ready-made equation for objects which are moving on a plane, inclined plane. So if you are given an angle theta with horizontal, you should be careful. If it is given with vertical, you have to calculate theta, which is angle with respect to horizontal. In that case, viscous force will be simply W sin theta. So F equal to W sin theta would be a ready-made equation for inclined plane problems in viscosity. Now further, W 200 Newton sin theta, we know that it is theta is 21.8. I can always substitute. Fv is in terms of mu, I have taken from here. So it is 0.25 multiplied by mu into 0.4 by 5 into 10 raised to minus 3. Now from this equation, the only unknown is mu. If you calculate, you will get mu as 3.7138 Pascal second. Okay, there we'll stop. Thank you.